When creating families, we are often required to form such geometry that can rotate at different angles when you change a particular parameter value. We already did this when we created the door opening symbol, but there we had a simple 2D line that could rotate. What if we need the 3D geometry rotation? Let's try to figure it out at this step. First, I'll create a family based on the metric generic model template. There are two intersecting reference planes inside of it, and we will rotate the geometry relative to them. The angular dimension, to which we will assign the parameter, should be attached to the line. We had a line for the door opening symbol, but 3D geometry is not that kind of line. However, among the shapes we can use to create 3D solids, there is one that is created from a line. This is a sweep form, with the path exactly the one that we can easily snap through an angular dimension. Let's create a sweep and go to the path editing. We will draw a line from the reference plane's intersection. The work plane will be formed on this line for the profile creation. The line's end must be snapped to the reference planes so that the path beginning cannot be moved in the X and Y directions. Let's do this through alignment. Snapping a vertical plane will inhibit the movement along the X-axis. Snapping to the horizontal one will block the Y-axis movement. Now our path end is fixed. We can also set the trajectory line length through the parameter. Let's build this dimension. And associate it with the parameter. I will name this parameter as L and make it an instance one. Let's finish the trajectory editing. We don't have a suitable orthogonal view to draw the profile. Therefore, the only view that will suit us is the 3D view. Let's go to it. And select the work plane for creating a profile. Next, we will activate the Edit Profile command. Suppose I will create a circular section profile. Select the Circle Drawing tool and draw the circle from the center of the work plane. Here we have a temporary radius size, but there is no icon allowing us to turn it into a permanent one, so that we will build size ourselves. The dimension text height seems to be large relative to the view scale. Let's change the scale. Let's associate this dimension with the parameter. I'll name it R. It will be an instance parameter. Let's check how everything works. And complete the profile construction and sweep as a whole. So, we have a sweep shape. I will get back to the ref level floor plan. Now we need to parameterize the rotation. Obviously, we can do it through the angular dimension, but after the sweep constructing, we cannot snap the dimension its center line. When I try to do this, the attachment simply doesn't occur. Therefore, this option doesn't suit us. Select the sweep geometry again and return to the edit mode. Here we see the trajectory line, but we cannot attach to it either. There is no binding. Let's move on to the trajectory editing itself. We already have a line. Let's try to set the angular dimension. And this is where it works. I will assign a parameter to this angular dimension. Name it as angle. And this is also be an instance parameter. Let's exit from the edit mode again and check how the rotation works. There shouldn't be any problems with angles ranging from 0 to 90 degrees. We see that the rotation is normal. Next, let's go beyond 90 degrees. The rotation also went well. We put 180. And there were no problems here either. But if we set the angle to more than 180 in old version of Revit, then the software will give an error. Dependencies are not executed. Actually, it's not a big deal, because in the project file, family will work without any errors, and in Revit 2022, it works in Family Editor as well. Sometimes we need to create a family with the extrusion geometry that will also have to rotate. Let's create a new family. Select the metric generic model template again. Let's build the simplest extrusion element here, a cube for example. Let's attach its edges to the central reference planes. And create a parameter responsible for the dimensions. For example, I will assign the parameter A to both dimensions. And this parameter will also be set to the extrusion end attribute. That is, all the cube dimensions will be equal. Let's complete the construction. Making this extrusion rotate is quite problematic. In general, if we need to shape a rotation for some complex geometry that doesn't constitute a sweep, it is better to nest it in another family. Moreover, for this attachment, we will set a particular parameter called workplane-based, responsible for the ability to place family instances in the parent family or the project by binding to the selected workplane. Now, let's create another family where we will nest our cube. Select the metric generic model, template again, and draw a reference line here. We will snap to the initial reference plane's intersection and fix the movement of this line. We will also create a parameter that will be responsible for its length. By analogy with the previous family, where we formed the sweep, I will call this parameter L. And we also need an angular parameter. First, create the appropriate dimension, and then link it to a parameter. That is, we did almost all the same as for the sweep path, but in this case, the line will serve as the basis for the cube placement. When I move the cursor over the reference line, a blue rectangle appears. This rectangle actually can serve as a work plane for placing another object. Let's switch to the 3D view. Here I will move the mouse cursor over the same line. Then we will see several planes. Each of them can become a work plane. Let's load our cube into this family. Its name is Family 2, and the one where the auxiliary line is located is called Family 3. Your family names may differ. If I use these families not only for the lesson but also at work, then I would first save them before loading into the project or the parent family to give them the correct names. Otherwise, they will be called Family 4, Family 5, and so on, which will not allow them to be properly identified during further work. Mark the name of the parent family with the checkbox and load it. Let's go to the 3D view. I have no opportunity to place a cube instance, so far a prohibiting sign appears. And besides, when it comes to the 3D view, the reference level is set at the work plane by default. We generally have only one level, ref, inside of the family. This is accordingly a working plane. We need to change it. Go to the Create tab and select the Set Work Plane command. Next, I will set the Pick a Plane option and move the mouse cursor over the reference line's end. We want the work plane to be highlighted. Sometimes we may highlight a wrong planes. In such case, it will be best to use the Tab key to iterate it over. But everything is fine here. I click on the plane. Now it works. You can click the Show Work Plane button to see it. And now we can place the cube instance. To do this, select the Component command. This command allows us to place the nested family instances. We have only one family of this type, so Revit provides it to us for placement. But it is not possible to place instances. Instead of a mouse cursor, I have a prohibiting sign, but there is a Place on Work Plane command on the ribbon. I will activate it, and now the cube is placed. I can snap it to any position on the work plane, such as the center of the plane. Let's reduce the object dimensions and return to the ref level. We see how we placed the cube here. Its base center is at the end of the line. If you want to get any other reference, that the most advantageous way to do it is to place the geometry within the cube family relative to the intersection of its initial planes at a specific offset. Then, these offsets would be reflected here as well. In the parent family, of course, you can also set some offsets through dimensions and parameters. Let's try to change the angle. We see that the cube moves following the end of the line, but the geometry doesn't rotate. Let's fix this. I'll undo the last action. Set the angular dimension between the reference plane within the cube family and the reference line. This dimension equals 0. Select it and close the lock. Now try to change the angle again. We see that now the cube is rotating, but there is another problem. We have an offset between cube and reference line. Let's set a parallel dimension between these objects. Select the cube and set the size to 0. And close the lock. Now the rotation takes place without any displacement or other problems. You can create any rotated geometry within Revit families this way.